Hello, and welcome back to Introduction to Astronomy. In our previous segment, we were talking about the rocks and minerals that make up the Earth. So now we want to start talking about the structure of the Earth, but before we can do that, we need to talk about why is the inside of the Earth hot? Well, how do we know that the inside of the Earth is hot? Well, even the ancient Greeks knew that because they saw these things called volcanoes and they saw all of this molten material coming out of them. So that gives us a clue that the inside of the Earth is hot. So why would the Earth be hot? Well, maybe it's hot because of the sun. But no, that's not true. So the energy that we get from the sun heats up the atmosphere of the Earth, and it is responsible for generating the Earth's weather, but it's not responsible for making the inside of the Earth hot. Okay, so what would make the inside of the Earth hot? Okay, one is the original heat from the formation of the Earth itself. So we think that the Earth formed as a result of collisions of different kinds of asteroids. Now imagine the asteroid that killed off the dinosaurs was only about 10 kilometers in diameter, but yet it gave off millions of atom bombs worth of energy, one impact. Now think about how many of those kinds of asteroids it would take to make an object the size of the Earth. So again, millions of them. So that would be million times millions of atom bombs, and that's the amount of energy that the Earth has. So the Earth is hot because it was hot from its initial formation. Another reason why the Earth is hot is because of radioactivity. So inside the Earth there's uranium and thorium and other kinds of radioactive elements, and as they fall apart through a process called nuclear fusion or nuclear fission, that releases energy that keeps the inside of the Earth hot. Then you also have another kind of energy called gravitational energy. And so this is what happens whenever you take an object and you drop it. Its potential energy turns into kinetic energy. So inside the Earth was a lot of iron, a very dense material, and it was uniformly distributed throughout the Earth. But then that iron, because it was more dense, started to fall towards the core. And so as it fell, it gave off potential energy, turned into kinetic energy, and that's another reason why the inside of the Earth is hot. All right. So now let's talk about what density is. So I already mentioned it in a previous episode, but here's the formula for it. Density is how compact an object is. It's going to be the mass m of an object divided by its volume v. Now the key thing to remember though is that more dense things will sink into a less dense thing. Or another way of saying it is a less dense thing will float on top of a more dense thing. That's the key thing to keep in mind, because we talked about iron, which is a very dense material, and how it flowed to the center of the planet because it's more dense. Density is also going to be useful in explaining why you have convection of materials, which we'll talk about in just a few moments. So in case you're wondering about a mathematical example of this, imagine that you've got a refrigerator that has a mass of 113 kilograms, which is 250 pounds, and it has a volume of 1.03 cubic meters. What would its density be? Okay, so that you're going to write down the mass, the volume, you're looking for the density, plug in the numbers, you get 110 kilograms per cubic meter, and the density of water is 1,000 kilograms per cubic meter, so that if you threw this refrigerator into the water, it would actually float. at least until it filled up with water. So here's the density of typical objects given in kilograms per cubic meter. And so again, if you look at water, it's 997 kilograms per cubic meter, which is approximately 1,000. So how does heat move inside the Earth? Tell you what, let's talk about this in our next segment.